on this page, we're trying to determine intercepts. And so in this case, this is just asking us to make sure we know what intercepts mean. There's no actual calculation, we're just reading this from a graph. So here are my x and y intercepts. I can read these off the graph. My x-intercepts are -1, 0, and 3, 0 from these 2 points. And my y-intercept is the point 0, 3 from this point. The vertex of a parabola, we learn that if the equation of the parabola has the form ax squared plus bx plus c, then the x-coordinate of the vertex, which we often denote h, just to be consistent, the x-coordinate of the vertex is given by the formula minus b over 2a. So in this case, that's minus 6 over 2a will be -2. So I have a negative 3. So when the x-coordinate of the vertex is 3, so the y-coordinate is going to be, call that k, is going to be f of 3. It's going to be what you get when you put the x-coordinate into the formula. So that's -9 plus 18 minus 10 is -1. So the vertex should be at the point 3, -1. This equation seems harder to solve because it doesn't have it's not just t squared, but we don't have very much understanding, or we don't know very much about how to factor quadratic polynomials. So the only thing that we know beyond quadratic polynomials is that if every term in an expression has a common factor, then we can factor out that common factor. So that's what you should be looking for if your polynomial is not just second degree. In this case, you can see that every term has a t squared that can be factored out of it, and every term has a 5 that can be factored out of it. So, in fact, I might as well factor out a -5, so I don't have to look at that crazy negative sign in front of the whole expression. So I can do a little bit of factoring without having to get into the general theory of factoring polynomials. So I'm going to factor a -5t squared out of every term. What's left behind for the first term is t squared. And just stop and check. If we were to distribute this, the product of these two things, -5t squared and t squared, would be -5t to the 4th, which is this term. And I'll have plus 2t. And again, stop and think about how this is going to distribute. This -5t squared times the 2t, -5 times the 2 is -10, t times t squared is t cubed. And then minus 24. And I may have to get a calculator out for that, but again, 5 times 24 is 120, but I want this to be -24, because -5 times -24 should be positive 120. And of course the t squared is still there. So we can do that factoring, so it should be that equal to 0. And so now I want to see if I can actually factor the quadratic using the methods that I already know. And so this would be a case where I need two numbers who have a product of -24 and a sum of +2. And this will happen when I have +6 and -4. My +6 and -4 will add up to 2 and multiply together to be -24. So this is my complete factorization. So the reason that I want that is because that means that one of these factors has to be 0. So no matter how many factors I have, if the product is 0, then one of the factors has to be 0. In each case, I can solve the equation. The only way for -5t squared to be 0 is if t is 0. The only way for t plus 6 to be 0 is if t is -6. And the only way for t minus 4 to be 0 is if t equals 4. So my solution set, my solution set is 0, -6, and 4. If we have a factored polynomial, then it's very easy to understand what the x-intercepts are, because remember, the x-intercepts happen when f of x equal to 0. So if your f of x is already factored, as it is in all of the problems in section 5.1, then all we have to do is know when those factors are 0. So the only way for the f of x to be 0 is if f of x minus 7 is 0, or x minus 4 is 0, or x plus 4 is 0, or x minus 1 is 0. So my intercepts are going to happen when x is 7, x is 4, x is negative 4, or x equals 1. So that gives me 4 points. I could put that comma 0 for the point. Now the problem also asks for each of them. Let me write those points. So I have 4 x-intercepts. For each one, I can tell from the multiplicity in the factorization whether the graph just touches the x-axis or passes through. And what I'm looking for here is just even or odd powers. So each of these factors is only occurring to the first power. So the first power is an odd number. I'm running out of room here again. So these factors have an odd power, and so an odd power indicates that the graph actually passes through the axis for those intercepts. So I'm just going to mark those on here. That this intercept, and this intercept, for those the graph passes through the x-axis. For the other one, this one has an even power for its multiplicity, so this guy has an even power, and so at that root, at that x-intercept, we just touch the axis. So the evenness or oddness of the power in the factorization tells us whether the graph passes through or just touches. And if you're not sure, draw this on your calculator. You'll take some doing with your window, but you can draw it on a calculator and see that really is correct characterization of those two things. So we see that more in this problem. The fact that this power is even tells us that the graph should just touch the x-axis at this x-intercept. This x-intercept is going to be when x is negative 6, y is 0. And because this has an odd power, you should be passing through the x-axis at the intercept 3, 0. So this only has 2 x-intercepts, at negative 6 and at 3, and at 1 you're touching and at 1 you're passing through. And so if you know that, it's not too hard to find the right answer. It's going to be, it's going to be one of these two. It's hard to fit on my screen here. So I'm looking for touching at negative 6 and passing through at 3, and so the only two that do that are these two. So right away I know it's not that one and it's not that one. And so how do I know which of these it is? Well, just look at the difference. One of these has a y-intercept way up here, and the other one has a y-intercept way down there. So the y-intercept is something else that's easy to calculate. So let's calculate our y-intercept, and we'll know which one it is. The y-intercept, remember, happens at when you put 0 in for x. So if I put 0 in for x, I'm going to have negative 2 times 6 squared times 0 minus 3. So if you do this calculation, you'll find out that the answer is positive 200 and something. So this guy has a y-intercept that's positive 200 and something, and so this must be the right answer.